Good afternoon, viewers. Welcome back to Easy Mathematics. Today, we want to look at the first part in measurement and geometry and measurement, or geometry and construction. Today, we want to look at the right angle triangle, what is a topic for Basic 8 and also for the Form 3 candidates. Now, with the right angle triangle, when we're looking at the types of triangle, we mentioned this type of triangle. We said the right angle triangle is an angle, is a triangle having one of the angles at 90 degrees. That makes us call that angle right angled triangle. So today we are going to look at some special properties about this right angle triangle. Now, in looking at the properties of this right angle triangle, we consider a theorem which is known as the Pythagoras theorem. So with the help of this theorem, we can look at whatever we have to look for today. Now, let's take this triangle ABC as our right angle triangle. Now, you see that every right angle triangle is having a longest side, or it's like having one side being the longest among the three sides. So the name given to the longest side, which is constant, is known as the hypotenuse. So the longest side of the triangle, which is the right angle triangle, is referred to as the what? The hypotenuse. Very, very important. We have to take note of it, that the longest side is always the hypotenuse. Now the remaining two sides, they changes. Okay, as this is the adjacent, sometimes it becomes the opposite. And as this one being the opposite, sometimes it becomes the adjacent. Now, how can the name change? Now, with the right angle triangle, the name of the other two sides changes depending on the location of this angle, which is theta. Now, theta is used to represent unknown angle. So the position of the theta help us to know the name of the other two sides. So if I write my theta here, then the opposite side, or the side of the triangle being opposite to the theta, is referred to as the opposite line. So this line is the opposite depending on where the angle is located, and the other side is given the what? The adjacent. So now, assuming that I'm able to get my angle here, let's say theta, you will notice that this side of the triangle becomes opposite to the what? To the angle. So we are going to give this side the what? The opposite. And this side becomes the what? The adjacent. That is why I'm saying that with the opposite and the adjacent, it changes. But the constant name, which doesn't change, is the longest side. Good. Now, this Pythagoras theorem, it states that the square of the longest side, which is the hypotenuse, if you square the hypotenuse, and you square the adjacent, and you also square the opposite, putting the two together will give you the hypotenuse square. So the theorem states that the square on the hypotenuse, is equal to the square on the adjacent plus the square on the opposite. That is what the theorem states. And this theorem works for only right angle triangle. So now that I know that with the Pythagoras theorem, the longest side being the hypotenuse squared is equal to the adjacent squared plus the opposite squared, I can solve any question given to me based on right angle triangle. So with this theorem, we can solve for the hypotenuse if we have this and this. We can also solve for the adjacent if we have the hypotenuse and the opposite. We can also solve for the opposite when we have the adjacent and the hypotenuse. So in terms of vectors, we have the AC being the longest side as the what? The hypotenuse. So the AC squared is equal to the adjacent in terms of vertex. The adjacent is what? AB. adjacent squared plus the opposite BC squared. And this is the most important thing we have to know when it comes to the Pythagoras theorem. Because the theorem is saying, we have to know what the theorem is saying, that the square of the hypotenuse, what is the hypotenuse? The hypotenuse is the longest side of the triangle. So the square of the hypotenuse is equal to the opposite square plus the adjacent square. The opposite square plus the adjacent square gives you the hypotenuse squared. This is what the theorem is saying. So with the help of this theorem, we can solve numerous examples using the Pythagoras theorem. Good. So now, with this few explanations, let's take an example, or let's take more examples on how to use the Pythagoras theorem in solving problems. Now look at the first example. You have to find PQ. And this is P, this is Q. So the line PQ. Now if you want PQ, first of all ask yourself, which side, or what is the name given to PQ? We said the longest side is the hypotenuse. So if PQ is the longest side, it becomes the what? The hypotenuse. So in terms of vectors, we can say the PQ squared, which is the hypotenuse, is equal to any of this side. Either you bring this one first, it doesn't matter. When we get to the other level where it matters, we'll look at it. So now, this plus this, and the opposite and adjacent. So here, since there is no theta, we can take any side as the opposite and also as the adjacent. So we can say PR squared plus, then this one, RQ squared. So this is the theorem. This is what the theorem is saying. The hypotenuse. So we've squared the hypotenuse and we equate it to the square of the other two sides. So what is the hypotenuse? We don't know. So we are solving for it. So we have PQ squared. Don't get rid of the square. Is equal to PQ squared. What is a PR squared? Sorry. What is the length in terms of figures? What is the length given to PR? PR, they are saying is 4 centimeters. So we are going to substitute the PR with 4 centimeters. So we are going to say 4 centimeters squared. And this is, this plus RQ. RQ is going to give us what? This is 3 centimeters. So we substitute it with it as 3 centimeters squared. The squared is for everything. So just square everything. The square is for everything. So it's for the 4, it's for the centimeters, this one is also for the 3, it's also for the what? The centimeters. Or you can just choose to ignore it if you think that is going to be tough for you. So we can just write it as just our level. Since this one we are not going to be penalized, we can say 4 squared centimeters plus 3 squared centimeters, like this. You can just take it like this. Good. So now from here, we just saw 4 squared. So this is going to give you PQ squared is equal to the square of 4. Or 4 squared simply means 4 multiplying itself 2 times. So this is going to give us what? 16 centimeters. Plus, then 3 squared is also 3 times 3, which is going to give you 9 centimeters. So put the 2 together. You have PQ squared is equal to 25 centimeters. From here, our interest is to let the PQ be alone. But there is square attached to the Q, which is the PQ. So what do? We are going to square root both sides. So this 25, we will square root this side and square root the 25. So we are going to get the PQ as like PQ to give us what? 5 centimeters. Because the square root of 5 of 25 is 5. Now with the square root, the meaning is that if you have something like this, it means what number can it multiply itself to give you the number in the square root. So if you look at your 5 times table, you notice that 5 times 5 is giving you what? 25. So the number times itself, that will give you the number in the square root, becomes the what? The answer. And that is all about the Pythagoras theorem. You just state what it says, solve for the unknown, then we are good to go. Okay, let's look at the second example. If let's say this wasn't clear, with the second example, we'll be able to understand more about the Pythagoras theorem. Now you have to find xz. Where is xz? This is xz. Now if this is xz, how can I calculate for the xz? First of all, state the theorem. What does the theorem say? Or what does the theorem state? The Pythagoras theorem states that the longest side, which is the hypotenuse, squared, is equal to the square of the other two sides. So in terms of vectors, my hypotenuse is xy. So the line xy squared. Now this is my hypotenuse, which is equal to the other two sides squared. So if I take this and this, I can say xz squared plus this side being zy also squared. Now this is what the Pythagoras theorem states. Now that we've written the Pythagoras theorem, or what the theorem states, let's substitute. Looking at the length we have been given, substitute with the figures. So here, xy. Have I been given xy? I've been given xy as 13 centimeters. So I can choose to work without the unit, and my final answer, I just make sure I bring back my what? My unit. So the xy is 13. Now this is xy squared. So I'm going to write 13 squared, which is the hypotenuse. Now this is equal to xz squared. Now come back to the diagram and find out if you have been given xz. xz, there is nothing there, meaning I'm looking for this angle, this line or this side. So I'll maintain the xz squared plus zy. So now check if you have been given zy. You have been given as what? As 5. So to ignore this unit, I can write 5 squared. Remember, the theorem is with square. So if you write without a square, you are going to get your answer to be what? To be wrong. So now, let's try to get rid of the squares of the ones we can. Now what is 13 squared? 13 squared simply means 13 multiplying itself 2 times. So 13 times 13. And that will give you 169. 169. Then we equate this to this. We don't know. So let's keep maintaining it. Plus the square of this is 25. Now I want this. How can I solve for this? Now assume this thing is x and we are making x the subject or making y the subject. How are we going to do that? By lifting the positive 25 to this side, we will let this one stand alone. So this is going to give us 169 minus 25 is equal to xz squared. We are just lifting this one to this so that this one can stand alone or it can be alone. Now after subtracting, what are we going to do? We are going to get 144 as our answer, because this minus this is 144. Then we equate this to xz squared. Look at what the question is saying. The question said find xz, but there is a square attached to the xz. So what do? I am going to square root both sides. So square root this one, which is 144, and also square root the line xz squared. Now once you square root, the square on this one will cancel the square root, or the square root will cancel the square. Then you are now left with what? Line xz. Now this is the square root of 144. Ask yourself, what times itself will give you 144? What number times itself will give you 144? Reciting your times table, you will notice that 12 times 12 is 144. So if 12 times 12 is 144, then what is the value of xz? So we can state our answer as, therefore, line xz is equal to 12 centimeters. And that is all about the Pythagoras theorem. That is all about it. So once you are able to state what the theorem says, you can calculate for your work. Good. Now let's look at the third one. In the diagram below, calculate line QR. Line QR. So we want the length for this line. How can we calculate for line QR? Now, to calculate for line QR, we can take this triangle as 1 on each pole and calculate for QN. Then we can also take this triangle on each pole and calculate for what? NR. Whatever we get for this, we put it together. So now, let's first solve for this side. Now, taking this as a triangle, what is the hypotenuse? The hypotenuse is the longest side. So we are going to say the hypotenuse squared is equal to the other two side squares. What are the other two sides? The other two sides are this and this. Since we are concentrating on this one, so we can say Pn squared plus Q or NQ squared. Now let's just do our substitution. With the substitution, look at what the question has given you. PQ, which is the same as this side. So 13 squared. So 13 squared is equal to Pn, which is 12 squared. Plus, we don't know this one, so we maintain it. The angle, the line, NQ squared. So now, what is 12 squared? 12 times 12. 13 times 13. So 169 is equal to 144. Because the square of this is this. Then we add it to the line this. Now how do you get this one? Group like terms. Giving you 169 minus 144 is equal to NQ squared. Subtract, what are we having? We have 25 is equal to NQ squared. From here, what do? Square root both sides. So square root both sides will give you the square root of 25 is equal to NQ squared. Also square root this side. So 2 will square this, or will cancel out, then giving you 5 is equal to what? The line NQ. So this side is 5. Now you also do the same thing for this triangle. Remember we said the Pythagoras theorem works for only right-angled triangle. So let's also use the right-angled triangle with the Pythagoras theorem to solve for this. What is the longest side? The longest side is PR. So we can say the PR squared is equal to this side We can say NR also squared plus this side. We can also say PN squared. What do we have for the hypotenuse? We have 15. What do we have for this one? We don't have anything, so we will maintain it squared. Then this one is 12. So also square. Sorry, remember you are not to forget the square. So the square of this value is giving us what? 225. Then we have NR squared. Now the square of 12 is giving us 144. So we group like terms. By taking this one to this side will help us to know the value of NR. So we are going to say 25 minus 144 is equal to NR squared. Now let's subtract. Subtracting is going to give us the value 60. Let's see, 25 114. This will give you 1. Subtracting this from this is going to give you 8. So that gives us 81. So we have this as 81 is equal to NR squared. You want NR, not NR squared. So we square root both sides. So we have the square root of 81 is equal to the NR squared, also square root. Because we want to get rid of the square. So this will cancel out this. Now, what number times itself will give you 81? 9 times itself will give you this. So we can say NR is equal to 9. Now, if this side is also 9, and you have been asked to calculate QR, you can just say QR is equal to 5 plus 9, which is equal to 14. Now, we are not writing any unit because the question has not given us any unit. Take note of that. So if the question gives you unit, or you are being given unit, work with the unit or work without the unit. By your final answer, make sure you bring the unit. Very, very important. So this is all about right angle triangle. And I can say this is one of the cheapest topic in core mathematics. What you should know is that the longest side of the triangle, being the hypotenuse squared, is equal to the sum of the other two sides, also squared. We apologize for how we are speeding. Currently the weather is not favoring us, so we have to run and quickly provide the solutions. And look at the last one for the day. It says that in the diagram below, so in this diagram, AB is equal to BC. And AC is 8 centimeters. Find BD. Where is BD? This is B, this is D. So we want this side. We want this side. But how can I know? And how can I solve for it? Once there is a 90 degrees symbol there, or there is a 90 degrees, or the triangle is at right angle, then we use the Pythagoras theorem. So let's take this side as our right angle triangle. What is the longest side? In terms of vectors, this is the longest side, isn't it? Good. Now, I have this, and this is what I'm looking for. And I have CD. Have I been given CD? Yes, I've been given CD, but hidden in the question. Now, when we're reading the question, it says that AB is equal to BC. So this length are the same. Once the lengths are the same, this triangle becomes an isosceles triangle. So if there should be a line from the apex B here down here, we will divide these two lines. We'll divide this line into two equal parts. Why? Because the triangle is an isosceles. So if I want the length for this one, it is automatically 4 centimeters. It only divides since this is an isosceles. So quickly, we are going to say the hypotenuse square, which is BC, is equal to the other two sides squared. So BD is what we are looking for. So we can say BD squared plus DC squared. With this one, we are not concentrating on which side is the opposite or which side is the adjacent. With the calculation, we can just mix the sides. So BD is what I want. BC. Have I been given BC? From the question, it's 5 centimeters. So I can say 5 squared is equal to BD squared is what I'm looking for. So I have BD plus DC, which is what? 4 centimeters or 4 squared. Now the square of this is giving you 25. Then we have BD squared plus 16. Because the square of 4 is 16. Now we group like terms. So 25 minus 16 is equal to BD squared. If you subtract, what are we getting? We are getting 9 is equal to BD squared. Now what do we do from here? We want BD, but there is a square on BD. So what do we do? Square root both sides. So this is going to give me the square root of this number 9 is equal to the square root of BD squared. So the square will cancel the square root, or the square root will cancel out the square root, leaving behind BD. So what number times itself will give you the number in the square root? 3. So the question says find the length BD. So we can say therefore the length BD is equal to 3 centimeters. We are done. And that is all about the what? The Pythagoras theorem. We really apologize for how we are speeding. The weather is not that favoring, so it's not favoring us. Any moment it will rain. So we have to quickly go through today's lesson. Good. So under the Pythagoras theorem, that is what we have to know. This one, what the Pythagoras theorem states. The theorem is saying that the hypotenuse squared, the hypotenuse being the longest side square, is equal to the other two sides also squared summed together. Remember, we've explained why is the opposite is the adjacent. Now, next time when we meet, we will also talk more about the angles in the Pythagoras theorem, where we are going to look at or consider the SOHCAHTOA in basic 8. Good. So, working out the length, we don't normally take into consideration the actual opposite and the actual adjacent. But only when we are looking at the angle is where we take into consideration the opposite and the adjacent. But for now, let's know that the Pythagoras theorem is saying that the hypotenuse, the longest side, if you square it, is the same as the other two sides being squared. And with that, we've been able to solve for this too. When we meet next time, we'll take more solutions on the Pythagoras theorem before we look at the applications of the Pythagoras theorem, where the person will say a ladder is leaning against a wall. Thank you for staying tuned. See you next time. The name is Christian. Please subscribe. Beg you, subscribe. Subscribe. Thank you very much. Bye-bye.